All right. In this, we're going to talk about comparing two sample means to each other. Swim coaches have always questioned whether one gender tapers better than the other, meaning when they, at the end of the season, when they lighten up the workload, who responds better and goes faster or drops more time. At a championship meet, a simple random sample is taken and the 200 freestyle and time drops are noted. So I really did gather this data. A negative means that it was a negative drop, meaning they got slower. Okay, so the first thing I'm going to do is just put this in my list 1 and list 2, and I'm going to pause and do that. I urge you to do the same. Okay, so I have completed, I put those in my lists, and I then did one variable stats, that stat calc menu, one variable stats for both the girls, list 1, and boys, list 2. And I calculated the sample means, sample deviations, sample means, sample deviations. Okay? Now let's talk about the distribution of sample means. So talking about shape, center, and spread of this sample mean calculation, what would it be centered around? Well, the difference between the two, right? 2.29 minus 1.76 is going to be what we center around. Our shape, well, we're going to hope that it's relatively, I'm going to put a little question mark in there, that it's relatively normal. We could use T statistic here. And the spread, well, if you go back and you look at your sheet of formulas, you'll remember it looks like this, and you'll remember we have so much information here that, they tell us the confidence interval is the statistic, which for us would be this centerpiece, plus or minus a critical value, so a T star for us, and the standard deviation of statistics. So you say, well, if I'm doing the difference in sample means, which I am, then here is the standard deviation for that statistic. So this is what will help me figure out the spread. Okay? So the confidence interval formula for this looks like this. So you can see this is the formula, and it of course comes out of this right here that we've got the difference. That's our statistic. We have a T star, and the sample or the deviation for our statistic. I've used S here as sample deviations instead of the sigmas. Okay, so if we wanted to do this, if we really wanted to make a, let's say, 95% confidence interval, let's go through the process real quick. So we have our typical statement. We're going to make a 99 or 95% confidence interval for the difference in time drops for boys and girls. It might be nice to make a note that we're going to do boys minus girls, girls minus boys, whatever. Now we do our plan piece of this. Okay, so we have a 2-sample T interval. We have a simple random sample. They were independent. I want to just maybe step back here for a second and remind you that this test or this work is very often mixed up with matched pair. And what I would always think to myself when I have two sets of data is it important that like girl 1 be paired with boy 1? And it's not. In this case, that's not important because they all swam the same event, so we really just want to compare this overall average to this overall average. Now, if it were a problem where we said, well, we had like 15 different events, so we picked a boy and girl in each event, then yes, then it is a matched pair. We're comparing, one event, both boy and girl. But in this case, that's not important. We do our 1/10 rule, and because we have such small samples, we should do a graphical check. You can see I've done that here, and I actually do have one outlier. And I'm going to proceed through this problem anyways, but at this point, normally we'd really just say, well, there's an outlier, so we can't assume normality. So you're going to forgive me here. I'm going to keep going, but yes, by rights, we should be stopping here because we don't have the distribution we need. So now we're to the do portion of this. So you'll go into that same old menu. You'll look for 2-sample T interval. I'm just having the data that was in list 1 and list 2. Leave the frequencies. and the confidence level was 90. You're going to have the pool. This is a special kind of situation where we assume that they have the same kind of spread and deviation. We're not ever going to assume that, so you can leave that as no. You hit calculate. Here is our, there's our interval. So let me create a little room for myself to write negative 2.095 and 1.0499. Now, after this, I'm going to do a hypothesis test on this data, and I just want to point out that, you know, the null will be there the same. The alternative will be that they're not. The fact that 0 is included in my interval should tell you right away what the outcome of my hypothesis test is going to be. Because if 0 is an outcome that's possible, that means they aren't different. So I'm going to fail to reject the null. Let's come back when we do that test. And our conclude. We are 95% confident that the interval from negative 2.095 to 1.0499 captures the true difference in the average time drop in the 200 freestyle for boys and girls after taper. So now let's talk about a hypothesis test. Okay, so our null, under our state, our null is that the average for boys, the average time drop, is equal to the average for girls. Remember, once you've used the subscript and you're with two samples, this can be enough. Your alternative, I just said, is there a difference? You certainly could redo this with a different inequality, but I'm just going to do not equal to. Our plan, if I could, I'm going to just leave this as, you know, it's the same plan as on the previous slide. So I'm just going to put C, previous portion of video. The do. I guess the one difference, of course, is this is a two-sample T test rather than an interval. Do. So you'll go and you'll find the two-sample t-test in that menu, and I still have them in lists. I did not equal to, and then again pooled, you'll say no. So you calculate, and let me write this down. We have a t-statistic, and I'm going to write down that it is negative 0.702. Let's talk degrees of freedom. You'll see something here, that a DF. We are not going to use that for our degrees of freedom. Degrees of freedom for a two-sample test is one less than the smaller sample. So we only had 12 boys. It's 11 degrees of freedom. We are only as exact as our weakest sample. Okay, p-value was 0.4925. So let's conclude. So one more time, what did we do? We're going to fail to reject the null. Why? Because the p-value is way too big. So what does that mean? We don't have enough evidence that there's a difference in the time drop. Okay, so not a lot of new things here. You know, pay attention to your plan that, again, we have to have independent samples. Make sure whenever you encounter something with two sets of data to ask yourself, is this a situation where it's important that data be paired, in which case I do a matched pair and I would condense it all down to one list of data, the difference. Or is it okay to leave them separate? In this case, I think it was pretty obvious because we had 15 girls and 12 boys, not really anywhere to pair those up. All right? But other than that, it follows pretty easily from the other tests we've done.